Let's look at series motors. As the name suggests, of course, the winding is connected in series with the armature. In shunt motor, the winding was connected in parallel with the armature. In this one, in series with the armature. As you can see, same current is flowing through the series winding as through the armature. If you want to show the complete circuit diagram, it will be series winding, armature resistance, induced voltage, and your source voltage. So that will be the circuit diagram of series motors. Now, in series motor, of course, as you saw, that the same current that flows through the armature has to go through the field. That means your field is not constant. In shunt motor, the field was constant. So in this case, the field is not constant. Initially, when there is no E0 and a very large current flows, the starting current is very large. The same large current is going to flow through the field, and what's going to happen? It's going to produce an extremely large starting torque, right? So basically, that extremely large starting torque in general is used to move very heavy loads. So in general, we don't operate the series motors without any load. The load is always connected to the shaft, because if there is no load, it's possible that that extremely large torque is going to produce such a large such a large speed that the mechanical damage can happen. Now, when it is moving at a regular speed, when you have the load connected and it is moving at the regular speed, the flux value, of course, is under control, and the speed depends upon how fast the heavy load needs to be moved and how much torque is required. It is working under normal condition, but once again, you don't start the motor without any load connected to it. Now, how to control the speed of the motor? There are two ways to control the speed of the motor. So one way is you have a rheostat variable resistor connected in parallel with the field winding. So this is the variable resistance, and this is your field winding. So what's going to happen? The current that is coming from the source, this current is going to be split in the field and this resistor. So now less current is flowing through the field, and that will drop the value of the flux from the field. And when that will drop the value of flux from the field, what's going to happen? N is inversely proportional to 1 over V. It is going to speed up. So it's going to speed up above a base speed. Now, if you want to reduce the value of speed below a base speed, then instead of connecting this R over here, you basically connect an R in series with the armature. In series with the armature. So now what's going to happen? This is total ES right here, from positive to negative, from positive here, negative here. Now some voltage will be dropped here, some voltage will be dropped here, some voltage will drop here, and whatever is left is E0. And E0 will be less than what it used to be, because some voltage is now dropping in the new resistor that you have put, right? So since E0 is going to be smaller than before, and E0 is directly proportional to the speed of rotation, the speed is going to be below the base speed. So that's how we control the speed of a series motor. Next, we're going to discuss compound motors.